Hey all you cool sabers, today we're going to talk about slope as a rate of change. So first of all, slope is used to describe the steepness of a straight line. So the higher the number, the steeper it is. In different situations, the slope is described as the rate of change. Okay, so we've got basically four kind of ways. I mean, two of these are kind of the same, so it's really two. So it's really three, ways we talk about it. So rise over run is one of the more common ways. When you're talking about a graph, that's a really good way to describe slope, is when we're, you look at the graph, you use rise over run, you figure it out. If you're given actual points, this guy over here is probably the best one. And you'll use that quite a bit, especially as we move forward in the unit. These two aren't necessarily useful ways to talk about slope, or to use slope. However, they are a great way to describe what slope is. Okay, so they're kind of just when you're talking about what it is, that's what you would use. Okay, so let's look at example number one here. So we're just given 2 points and we're going to graph this. All right, so to begin with, I'm going to draw. Now I can't use a ruler on here, so this is going to look really, really bad. Look at that. Steadiest hand in the world. Oh my God. I could be a surgeon. Alright, so we label our X and our Y. And I'll put like a little scale on here. I guess those are negatives. Better label it correctly. And then we'll go 2, 4, -2, -4. So there we go. So there's my scale. And I will plot my points. So there is my first one, that is -2, 3, -2, 3, and the other point was 3, -2, I believe. Yes. So we got 3, -2. So those are my 2 points. All right. So we draw a line that connects these 2 points, just like that. Make sure you make that sound when you make a line. That's very important, obviously. Okay, so we're going to figure out what the slope of this is. So the first thing you're going to do is you always want to just use the grid and make a right angle triangle between those 2 points. It can be on top, it can be below, it doesn't matter. But what you're going to then do is you're going to measure the rise. So here we've got 1, 2, 3, 4, 5. So we've got a rise of 5, and our run is 1, 2, 3, 4, 5. So our run is 5. All right. It is worth noting that starting from this point, because we always read left to right, so you look at the most left point and you go to the most right point, it is going down, so that rise is actually going to be negative. Okay, so we have -5 over 5. So remember that your run will always be positive. If you get a negative run, you've done it wrong. Okay, you can, if it's going down left to right, then it's going to have a negative rise. The slope should be negative when you're done, but your run will always be positive. All right. So what we can do from that is we can just say then, well, slope, which you may remember, we always use M. And again, I still don't know why we use M, but the M is rise over run. So our rise was -5 and our run was 5. And of course, -5 over 5 equals -1. All right, so M is equal to -1, and that is our slope. Okay, so that's just one way of doing it. The other way to do this is to use the formula, which is what the question actually wants us to do. So the formula up in that box there was M equals, we have Y2 minus Y1 over x2 minus x1. Now, the first thing you should do when you get this, or when you're doing it with the formula, before you start anything, is, and if the points are written out well, you don't have to rewrite them out for this, but I'm going to rewrite them so they're right here. That was my first point. That was my second point. Okay, and so what I'm going to do is I'm going to say, all right, so this first point, that's the x value, that's the y value. The second point, this was the x value, that was the y value. And now I say, over here we've got point 1. This is point 1. So I'm going to call that x1 and y1. Over here we have point 2. So I'm going to call it x2 and y2. Okay, take the time to label your points like that because it makes it a lot less likely that you'll make a mistake. Even if you know what you're doing, it's very easy to sub the wrong numbers in. I, on occasion, have been known to do that myself. So label your points. It'll save you a headache later on. So now when we go to use this, we see we've got y2 minus y1. So we say, well, where's y2? Well, there it is right there. So we have -2 minus, and y1 was 3. And then on the bottom, we had x2, which is right there. So that's 3 minus x1, which is -2. And just remember, if you're subbing in a negative number, you want to put those brackets around there so that you remember to change it up a bit, or change that. So this is just going to become -2. You wouldn't have to write this step, but I like it to... You just change that 3 minus -2 into 3 plus 2. Okay? And from there, we're left with -5 over 5, which, just like before, is equal to -1. So our slope is equal to -1, which we already knew, but now we definitely know. And so you can see using a graph is going to be better, or is often a little easier, but it's also much less precise, especially if your points are difficult. Like for instance, if you had points that involve decimals or fractions, it would be very difficult to use the rise over run method. But if you use the formula, it's always going to work perfectly. Okay? So, slope is a rate of change. So Hudson remembers that his ATV had 4 gallons of gasoline in the tank on Monday. After driving a total of 40 miles during the week, he has 2 gallons of gas remaining. All right? So, what is the slope of the graph representing for Hudson's observation? So what is it? So this is going to be... oh no, sorry, I'm jumping ahead. I was about to say what it represents. That's actually part B. So never mind. So let's just calculate it. So first we're going to draw the graph. All right, and this time I'm just going to graph it along the axis here. You can see my hand is still nice and steady. Perfect. So we're going to go up by 10s over here. I guess I'm going to go up by 5s, but I'm only going to write 10s. So I'm going to go 0, 10, 20, 30. That's a cool looking 3. And that's a terrible looking 0. All right, and then over here we'll go up 1, 2. So I'll just go every other box. Should fit very well. There we go. And of course we have to label this, so we will label this distance driven. And that was measured in miles. Okay, and then we had remaining gas. Remaining gas, and that was in gallons. All right, so what we know is that when he started with 4 gallons of gas. So I'm gonna do this blue just to make it look better, you know, because it already looks pretty bad. And then we said that after he drove 40 miles, he was down to 2. So after 40 miles, he was down to 2. So there you go. There's your 2 points. All right. And so we would draw our perfectly straight line using a perfect ruler. Okay. And like I said before, like it's always the same. You're always just going to create this right angled triangle like that by using the grid. All right. And then we're going to count. And you can see last time I drew it underneath, this time I drew it on top. It doesn't make a difference as long as you know which one is the rise and which one's the run. So our rise, remember, use your scale. So if you count these boxes, there's 4 boxes, but you have to look at the scale. So it's actually our rise there is going from 2 to 4, or 4 to 2 rather. So that's going to be 2. And once again, you'll notice reading left to right, it's going down. So that is actually going to be negative. Okay, our run, okay, goes from 0 to 40. And run is always positive, so it's just positive 40. Okay, so that's our rise, and that's our run. If you get mixed up which one's rise and run, remember the sun rises, it goes up, and the run, well, when you're running, you're not going to run up a cliff. That'd be That'd be a terrible idea. All right, so from that, we can figure this out. We can say that our slope is equal to rise over run. Okay, so our rise was -2 and our run was 40. That's an arrow. Let's see, so that reduces to -1/20, which we could, this is a case where even though I usually like decimals, because this is a word problem, you are going to use decimals. Word problems like this, almost always, that is really sloppy. Anyway, so you got -0.05. Yeah, the word problems, decimals are usually better. All right. So the question is, what does this slope represent? Okay. So this is going to be his fuel consumption rate. Okay. So in other words, like our slope here, if we think about what it is, the top, the rise was a change in the y. It was your change in y. Okay. So that was going to be, that was the change. We use a triangle to show change. It means delta. So your change in y over your change in x. Okay, so your change in y, or y-axis, measured gallons of gas. Gallons of gas. Oh my goodness. There we go. And then, okay, and then the bottom was measured in miles. If you're not sure what you're measuring, you always want to think about the actual units. So this is your change in gallons by your change in miles. So in other words, it was equal to -0.05, and that was gallons per mile. Gallons per mile. Okay? So that is obviously then just the fuel consumption rate. It's a measure of how much fuel we're using. So fuel consumption rate. Rate. It's always going to be a rate, right? And that's basically, oh, the only other thing that I forgot, I did forget to label my graph. Don't forget that. So we'll call this Hudson's ATV. Let's spell his name right though. Hudson's ATV. And that's it. Okay? So until next time, go Sabres.